Colors. Quick video on how to add and subtract radicals. I always say, well, just treat the radicals just like any variable. For example, if you have 3x squared plus 7x squared, all these are like terms, same base, same exponent, so you can combine like terms, 3 plus 7, 10x squared. I have 4x squared plus 7y squared. These are not like terms, so we leave it as is. Same thing if I have negative 2x squared plus 7x cubed, we leave it as is. These are not like terms. This is squared, this is cubed, so we leave it as is. We cannot combine that. If we have, for example, 3x squared minus y x squared, x squared. Notice that, of course, we have x squared. We may combine like terms, but here I cannot add or subtract. In this case, subtract the 3 and the y. So we can just, we can factor out. So we have 3 minus y times x squared. Minus. So we may combine the 3 and the y, but we can just do it. So that's what we are going to be doing when we deal with radicals. We have to make sure that the index and the radicand match in order to combine them. So let's do a couple of examples. This quickly. I'm going to write the problem and then going to stop sharing so it's easier for both of us. Well, you and for me. If I were to combine 2 radical 3 plus 8 radical 3, what about this is in the basics. 8 cube root of 2 minus 3 cube root of 7. What about if I have 6 fourth root of 2xy, oh boy, plus 3 fourth root of 2xy minus 5 cube root of 2xy. Let me start with those. Let me start sharing. Okay, let's see what we have. On the first one, 2 square root of 3, 8 square root of 3. Of course, those are like terms, so we may combine those two. Last time we check, 3 plus, what am I? 2 plus 8, 10 square root of 3, and we are done. It's going to be 10 square root of 3. 8 cube root of 2 minus 3 cube root of 7. The indices are different, so we leave this as is. We have here 6 times the fourth root of 2xy, 3 times the fourth root of 2xy, 5 cube root of 2xy. Only these two may be combined. So 6 plus 3, that would be giving 9, fourth root of 2xy minus 5 cube root of 2xy, and we leave it as this. And that will be it. What about if we have problems such as the ones I have here? Let me share what I got them from the student guide. I just changed the numbers a little bit, but they're very similar. We were on this other page before. Next following page, 314, you find this one. And we'll do later on, well, these are multiplication. Okay, so let's go ahead and practice this. Okay, let me stop this. Stop sharing. Okay. Okay, so of course I cannot add the square root of 18 with the square root of 50. However, notice that these are not in the simplest form. 18 is the same thing as 9 times 2. 50 is the same thing as 25 times 2. 9 times 2, 25 times 2. So if I were to write this one, it's going to be what? Just put it on here. Be 5 times. Just put the times. Equals to 5 times. Square root of 9 times 2. Notice that if I were to break it down, the square root of 9 will be 3. Goes out. And the 2 stays in. And 5 times 3, 15 radical 2. Plus, we can use the same strategy here. The square root of 25 is 5, but that 5 multiplies the 4. 5 times 4, that will be, let me just do it here, 4 times 5. Then the 2 stays inside because it was 50. 25 times 2. Last time we checked 4 times 5, that would be 20 radical 2. So now we can combine this. 15 plus 20, 35 radical 2, and we're done. Yeah, we can do the same strategy here. Of course, 8 is 4 times 2. This is on the square, and the square of 4 will be 2 radical 2. This here. 32 is 16 times 2. The square of 16, 4, and the 2 stays inside. So this is going to be equal to 3 times 2 radical 2, which is 3 times 2, 6 radical 2, minus 5 times something. I can see. Of course, the 32, we break it down 16 times 2, square root of 16 is 4, and the 2 stays the same. So inside, so it will be 4 radical 2. 5 times 4, that would be 20 radical 2. 16 minus 20, negative 14 radical 2. And that's how you combine the terms. Okay, what do we have here? Cube root of 5xy to the 9 plus cube root of 5xy. Let me double check something. Just do a quick sharing. I don't think this y is in there. Let's see, where am I? Yeah, again, this y doesn't, otherwise we cannot combine anything. Okay, so okay. So sharing. Okay, so what do we have here? Notice that y to the 9, the cube root of y to the 9 will be y cubed, and the 5 and the x stays the same. Okay, so this is going to be equal to y cubed cube root of 5x plus cube root of 5x. We cannot combine them, but we can just put them like factoring inside the combining, but not combining. In parentheses, we can say it's going to be parentheses y cube plus 1, coefficient here is 1, times cube root of 5x. That's cube root of 5x. Okay, and then this one, we have the 4 times the cube root of 24. Notice that this one can be breaking down as well. Now we're dealing with the cube root. So this is 4 times cube root of what? Factors of 24 with perfect cube roots. That will be 8 times 3. The cube root of 8 is 2. And the 2 multiplies the 4. So this is 4 times 2 cube root of 3. And 4 times 2, 8 cube root of 3. Okay, so we work on that one. Minus 5 stay quiet there. Now we need to break 81. Notice that here we left the 3. So use your instinct, just divide 81 by 3 to see if we get the perfect cube root. And 81 divided by 3 will be 27. Perfect number, because the cube root of 27 is actually 3. 3 times 3 times 3 times 3, 27. Now we have here 5 times. The 27 comes out as 3, and the other 3 stays inside. Cube root of 3. Last time we checked, 5 times 3, that will be 15. Cube root of 3. Now they're called the allied terms. 8 minus 15 equals to negative 7. Negative 7 cube root of 3. So the answer would be negative 7 cube root of 3. That's better. I hope this helps. Let's see if I can do it. Thank you. Fine. Let's try a couple of examples from your textbook. Share textbook there. Yeah, perfect. Okay, section 6.4, a couple of your problems. Let me write it here, and then we'll stop sharing the screen. We have 9 radical 50 minus 4 radical 2. We have, I'm doing the even ones because the odd one you have answers. Radical 12 plus 16 radical 27. You're working on my math lesson. Okay, next one, let me try. Come on. Okay, 12. Let me try this other one. 2 radical 128 minus radical 18 plus 4 radical 32. 5 cube. Cube root of 8, let me just put it on here 2 times, not 2 times, 4 times cube that minus 5 cube root of 24. Okay. One, big numbers. 5 cube root of 32 minus, just going to put 2 cube root of 108 plus 3 cube root of 256. So let's start with this. I forgot. Should I copy here? Of course, I always recommend my students to look for the smaller number and try to write everything based on the smaller number. So here we have a square root of 2. That will be your first instinct, just to divide this one by 2 to see if we get something there. Well, indeed, 50 is 25 times 2. So we can do the following. We can do this, going to be 9 times 25 times 2. Oh boy. Bad idea here. 25 times 2 minus 4 radical 2. But notice that 25 comes out as 5, and the 5 multiplies the 9. 9 times 5, 45, and the 2 stays inside. 45, 2 minus 4 radical 2. 45 minus 4, we get 41 radical 2, and we're done. What about here? We're dealing with square roots. So factor will be 4, 9, 16, 25, the ones that have perfect square roots. 12 is 6 times 2. That doesn't help me much. But also 12 is 4 times 3. So 12 is the same thing as 4 times 3. Now here the square root of 4 is 2 and the 3 stays inside. Okay, so the 3 will be my hint. What if I take 27 divided by 3 to see if I have something there? Oh yeah, that would be 9. And guess what? 9 is a perfect, it has a perfect square root. It's going to be 9 times 3. Okay, so now I believe we have everything that we need. So let's do the math. This is equal to, well, the 4 comes out as 2, and the 2 multiplies the 9. 9 times 2, it will be, well, 9 times 2 radical 3 plus 16 times. The 9 comes out as 3, and the other one, 3 stays the same. Well, 9 times 2 is 18 plus 48. 16 times 3, 48. And now we can just add the coefficients. A plus A, that will be 6. 6 radical 3. And we're done. This is 6 that like this on the way. 6 radical 3. Well, here we have, this is 32. As I said, I always start with the smaller number. 18 is 9 times 2. Okay. So the square root of 9 will be 3 and the 2 stays inside. So that will be my first thing. Okay, what if I take 32 divided by 2? That's 16 times 2. Perfect. And 16 has a perfect square root. What about half of 128? That will be 64. That will be 64 times 2. So I believe we have all the tools because we have here 2 times. The square root of 64 is 8. 8 times 8 is 64. And we leave the 2 inside. And 2 times 8, of course, that will be 16 radical 2. Now, there's a 1 here, the invisible 1 in front. Let me just put it here so you don't get confused. The square root of 9 would be 3, and the 2 stays inside. 1 times 3, that would be 3 radical 2. Plus 32, 16 times 2, so the 16 comes out as 4, so we have 4 times 4 radical 2. And last time we checked, 4 times 4, 16 radical 2. Radical 2, radical 2, we can combine them. 16 plus 16, 32, minus 9, 29, the square root of 2. And we're done. Of course, you can always pause the video. I'm going to erase. I noticed that I'm kind of stupid writing everything at once. So what if I have 4 cube root of 8 minus 5 cube root of 24? And now we're dealing with cube roots. What's the cube root of 8? Well, 2. Okay, so we got something here, and then 24 can be broken down as 8 times 3. Well, nothing. Well, let's see what we have. This is weird. So we have, this is equal to, let me just write down here, equal to 4 times cube root of 8 will be 2, and 4 times 2, 8, minus. Here we have 5 times cube root of 8 is 2, and this other 3 stays inside the radical. We broke 24 as 8 times 3. The cube root of 8 is 2, and the 3 stays inside. Cube. Okay, so then what else can we do? 5 times 2 cube root of 3. 5 times 2, that will be 10 cube root of 3. And we leave it as C because they don't have any common factor. It will be 8 minus 10 cube root of 3. I hope I wrote it correctly. Something was missing there, I don't know. I'll check the book later on. And then the last example that I wrote was 5 cube root of 32 minus 2 cube root of 108 plus 3 cube root of 256. Okay. Let's see what we can do with this one. Again, work with a smaller number, in this case 32. We know that 32 is the same thing as 8 times 4. And the cube root of 8 is 2. So the 4 will stay. Let's see what we have here. Minus 2 cube root of what? 108. Well, since the 4 is going to stay, why don't we take 108 and we divide it by 4 to see what we get? That would be 27 times 4. No coincidence, the cube root of 27 is 3. Plus 3 cube root of 256. Well, since I'm going to leave 4 here and 4 here, why don't we try to do 256 divided by 4 to see how much that is? I believe it's going to be 64 times 4. And no coincidence, the cube root of 64 is 4. Okay, so what do I have? This is equals to 5 times. This guy comes out as 2. The cube root of 8 is 2. And we leave the 3, the 4 inside the cube root. And last time we checked 5 times 2, that would be 10 cube root of 4. And let's repeat the process with the other 2, minus 2 times cube root of 27 would be 3, and the lovely 4 stays inside. 3, 4. 2 times 3, 6 cube root of 4. And here will be same, will be 3 times cube root of 64 is 4, and the lovely 4 stays inside. And 3 times 4, 12 cube root of 4. Now we just combine all of them. What is the coefficient here? We have 10 plus 12, 22, minus 6, or you can just do 10 minus 6, 4. 4 plus 12, 16. So I believe the final answer will be 16 cube root of 4. Thank you. Now I can leave.